Well, thank you for turning up after a good lunch. I'm sure most of you, like me, were tempted to sneak up to your room and have a snooze. You see by my title that I'm going to need at least a month to talk about this. I think I agreed to this in a naive moment without thinking about it, and then when I got to thinking about it, I figured, holy mackerel, in an hour I can only touch the tip of the iceberg. So what I'm going to focus on is a few water-related issues, and I'm going to focus on ones that I think should be of concern to First Nations communities, the majority of First Nations communities, which live across Canada's north and especially in Western Canada. The reason why I think we need to be concerned is that most of the development in Canada is in the south, the black dots on my map here, whereas most of the water either is in the north or flows that way. So Canada's sort of put together like an engineer would make an outhouse with three holes, one above the other, and all of the shit falls from down here, and you can see where it goes. Well, one of the things that we're going to see affecting us increasingly will be climate. Climate is something that people tend not to think of as having a big effect on water and especially water quality. But as you'll see in some of my examples, it underlies a lot of the other problems and enhances them. Things like land use change and inputs of nutrients from cities and so forth, hydroelectric dams which change flow of the water that should be headed north, and then also some things that come via the atmosphere to northern waters, like some of the contaminants. Well, if we look ahead, despite what the people who deny climate change say, we've already seen a pretty considerable climate warming. And if you look at this period between now and the middle of the century, all of the climate models are in pretty good agreement that we're going to see 2 or 3 more degrees. And we've already had a pretty considerable climate warming. Here are some examples that we've taken from Alberta weather records. We've chosen Edmonton International, and this record here is Calgary International. And Fort Chipewyan, people like Lorne Gunter for the Edmonton Journal always claims that it's all urban heat island effect. Well, somebody ought to take Lorne to Fort Chipewyan in the middle of January so you can see what kind of heat island effect there is there. So we've already seen a pretty considerable climate warming. We always hear about the global averages, but the interiors of continents get much higher warming than the global average, countered by less warming over the oceans in some areas. And if you look at any other number of measures, if you focus on a few examples here, again, like Fort Chip and high level, if you look at the number of frost-free days, we've had a 40% increase in 30 years. Fort Chip, a 30% increase. And it is warmer in the winter. We have maximum temperatures over -20, 30% more of the winter days in Fort Chip. There's no question climate's getting warmer, and unless 95% of the climate scientists in the world are wrong, we're going to see it get warmer again. Well, all of those rivers that I showed you coming off the prairies originate in the ice fields of the Rocky Mountains. And they've all been receding like crazy. This is the Athabasca, which I show you because it's the headwaters of the Athabasca River. This was 1919. It's receded, this picture taken in 1993, by 1.5 kilometers. And every year, on average, it's lost 16 million cubic meters of water, more than it's regained from that year's ice and snow. You can see that if we had 1919 conditions, we wouldn't have an ice fields center or an ice fields parkway. And the same for the headwaters of the North Saskatchewan. This is the Saskatchewan Glacier. 2002, way back here. This is more or less the same angle. And worst of all is the Bow Glacier here in 1898 and here in 2002. And if you look at that tree, this is the same tree over 100 years later. It's only lost a few branches, but look at the amount of ice that's been lost in that time. And some recent studies indicate that there's not enough ice in that glacier to continue yielding more water if climate warms. And of course, if you look at the prairies, on that first map of mine, there was a little gray area that was southern Saskatchewan and Alberta. That's an area where even in the 20th century, the wettest century in the last 20 centuries, paleoclimatologists will tell you, the evaporation always exceeds precipitation. And the reason that we can have Calgary and Medicine Hat and cities like that is because of the flows out of the Rocky Mountains, both the melting glaciers and the annual snowpacks. So you wonder, once these glaciers are gone, what are those rivers going to do for water in midsummer? And of course you come further downstream on rivers like the Athabasca and the North Saskatchewan, you're directly into areas that affect Aboriginal communities. Most people look at the projected warming and the precipitation, if it's mentioned at all. Most models don't show much change in precipitation, and they say, oh, it's going to be 2 or 3 degrees warmer, but the same amount of rainfall, it's going to be great here. What they forget is that evaporation follows temperature much more closely than it does precipitation. Here again are 2 examples taken from existing climate records showing that with the change in temperature we've had, most of it in the last 35 years or so, we've already had a 12 or 13% increase in evaporation in central to northern Alberta, and northern Saskatchewan would be much the same. And we've seen already the effects on river flows, particularly in midsummer. You can't get whole season records for this whole period shown here. So what we've done is to work with midsummer records. Probably in the early years of the 20th century, people couldn't get their horses through or their Model Ts to take the necessary measurements. So those records in early spring and late fall were typically missing. This is May through August flows, but this is also the time of the year that there's a lot of demand for that water, whether it be to float boats or to irrigate crops further down the river. Both the Peace and the Old Man are showing declines of about 40% from the average back here to the average here. And the worst of the lot of the several rivers that we've looked at is the South Saskatchewan. We actually have just added the 2001 to 2003 data, and those 3 years would be at about 16% of the historical flows back here. And if you talk of anybody who uses the rivers, historically they used to complain about not, complain about not being able to float ferry boats up and down the river. Now I hear people complaining about not being able to float their kayaks. So those rivers are already under a fair amount of stress. And the lakes are as well. This is Wabamun Lake just west of Edmonton. This is one of the cottage development. It's a lake with lots of conflict. There is the Paul Band First Nations community between the power plant over here and this picture back over here somewhere, with a good part of the lake shore who rely on that lake for fish and water. And the lake, of course, has all sorts of pollution problems. Well, on top of those changes to water quantity, of course, we have a threat of water warming per se. I'll show you later some evidence that as climate warms, water warms in proportion. And this group of mixed scientists from the US and Canada have used the Canada climate model to predict how much water temperature is going to change. You can see this color in most of Canada indicates a potential change of 5 or 6 degrees centigrade. Well, for most of the fish that we rely on, things like whitefish and lake trout, most of the big populations are already living in water that are within 2 or 3 degrees of their lethal temperatures. So if we push the temperatures as high as this, we're either going to see a big decline in fisheries or at best a replacement of those fisheries with warm water species like pike and walleye, where that's possible to happen. So to summarize the climate warming case and then go on to a couple of case histories, it's going to both affect water quantity, but if you put the same amount of pollutants via point sources into less water, you get higher concentrations of pollutants, so it will affect water quality as well. And I'll show you a eutrophication example, since this is the West and we don't have an acidification problem yet, though the oil sands are trying mighty hard to get us on the acid rain map. It's still largely an eastern problem. This is the Athabasca River, and I think it's a good example because the Athabasca is probably our biggest remaining headwater glacier, but also this is the only undammed major river in Alberta. Kind of disgusting when you think of all of the big waters that we have. So the effects that we see here aren't the effects of hydroelectric diversions or any big irrigation developments. There are water monitoring stations wherever you see a red dot on the map, and these are the summer flows in the early 1970s at the beginning of this period, and again midsummer flows, moving from upstream to downstream. Well, those flows have gone down over 30 years and down by quite a bit. You can see particularly in the lower part of the basin from Athabasca north, down by 20% or more. There's one exception to that decline, and that's the uppermost station at Sunwapta, where almost all of the water is generated by glacial melt. And that big glacier under warmer climate is melting faster. So it's increased, but that's a pretty small part of the basin. So in terms of overall flow, it's not much of an effect. In terms of July-August flow, when it's at maximum and everything else down in this area is dry, can be fairly important. If you look at the water yield per each of those basins, again, early and late, you see the water yield off of each of those has gone way down over that 30-year period. And again, because of the glaciers in the basin and the fact that as long as there's a big chunk of ice there, we can generate more water. That system has been, to some degree, countering the overall trend of the Athabasca. But if you look at the overall picture, the flow, this is at Fort McMurray, has gone down by about 30%. If you look at what the climate predictions will tell you, if you take this website down, you can actually call it up and you can put in your local community and a time period that you want to consider, and it'll run every major global climate model for you and plot the results of all of them. You can see there's a considerable variation. This is temperature increase on this axis and precipitation on this axis with the 0 point right here. Well, if you look at the predictions for 2020 or 2050, this is for the oil sands area. Most of the climate models, if you look at the scatter here, are predicting increases in precipitation of 5 or 10%. But if you look at how much evaporation has already increased, it's already outstripped that. If you look at what temperatures for 2050 would project, evaporation will be up here somewhere. So if the models are at all correct, We'll have more rain, but we'll also have a lot more evaporation, and the rain won't be enough to compensate for it. So we'll have much drier conditions on the ground with all of that means. Well, looking at the possible effects on development, this is something that Archie Walken will probably be talking more about later on. We have this oil sands development on the lower Athabasca, and all we ever hear via our news media is all the good things, all of the money it's generating for Alberta. If you try to drive there, you can drive this little ribbon along the way. There's nowhere to stop except where the companies want you to stop and take any pictures or look at anything. The scale is enormous. If you look at each one of these little squares here, it's 100 square kilometers. In other words, each of those is a township. By 2020, they're projecting about 20 of these projects, each of them about a township in size. If you sum all of those up, it means a pit that's 2,000 square kilometers. That's the size of a smaller European country or American state. Now, I doubt whether if you went to President Bush and said, well, there's oil sands under Rhode Island, guess we better dig it all up so we have energy security. I expect there'd be a somewhat different reaction than digging up northern Alberta. But this is what the oil sands looks like. This is the Athabasca River. These are polluted ponds and polluted tailings ponds, some of them several square kilometers in area. They're toxic enough that no one wants them to get dumped into the Athabasca River. I think it's inevitable some sort of big precipitation event or some earth tremor or something, and we're going to have a spill. And again, if you look at the walls separating those tailing ponds from the Athabasca, some of these are 300 feet high. And this oil polluted stuff seeps like crazy through it, and they catch it in this trough and pump it back over the top. How many thousand years are we going to put up with that happening? That area is never going to be anything but a toxic pit. They talk about restoration, but in fact, if you look at their restoration efforts for the oil sands, they might have tried to restore a fraction of a percent. And if you look at the results, they've been really pathetic. From a water standpoint, it's even more pathetic. Actually, these two photos are part of a panorama that would sweep about halfway around this room, where you see the same thing in every direction. Those plants use 6 barrels of water for every barrel of oil that they generate right now, to say nothing of using a barrel of oil or the energy equivalent for every 3 barrels that they generate. So it's a very inefficient process, and I would say totally unsustainable. Well, the red bars here are projected water use if they all pump from the Athabasca as the current plants do. This would be about half the winter flow of the Athabasca they'd be taking at that point. Well, the new companies claim they can go to 3 barrels of water per barrel of oil, so they can lower things to where the green bars are. It's one mistake here. This should be Alberta Energy and Utilities Board estimate, this yellow one. The blue are actual projected, actual measured licenses as compiled by some of my students. So water demand during this same period when glaciers are disappearing and climate's warming is going to increase for that area. And the other thing that's going to happen to the plumbing is that 56% of that oil sands area is what looks like about like what you see here. This would be called a wooded fen in scientific terms. It's basically a big mossy sponge, several meters thick, with some very old trees growing out of it. This has a very important effect on the flows of the Athabasca and its tributaries. It gets saturated during winter snow and big rainfall events, but it holds that water back on the landscape and releases it very slowly. And as anybody who's ever traveled or trapped in those areas will tell you, Middle of the winter, it can be 40 below, and if you're walking down a creek, you'll hear water gurgling under the ice where it's leaving some of this area. So it helps to sustain the flows during dry periods like the winter and periods of drought. Well, they strip that off, and the oil sands people will tell you they don't know how to put that back. And they've had international groups of scientists meet with them, and no one knows how to put that back. So this is what they call restoration. This is actually at Syncrude's PR site. This is what they call a restored wetland. It's sort of a grassy area with a pool in the bottom, and it doesn't function the same at all. So you can imagine those wetlands took thousands of years to develop. We're not going to put those back by some miracle of science in the next couple of decades. Our grandchildren are going to see those big open pits, and they're going to know that that's the price we paid to make money from all of the gas-guzzling SUVs. Well, let's go a little further downstream to the Peace Athabasca Delta. Very beautiful place, very rich in waterfowl and fish and wildlife originally, and in places it still is. There was another influence that was very important to that very flat country, and that was the flow of the Peace, which is even bigger than the flow of the Athabasca. Typically, the Peace would freeze 4 or 5 feet thick, and then when spring snowmelt started in British Columbia, where there's lots of snowpack, the water would come down, raise that thick ice pack, and sweep it downstream, and it would break up into big blocks. When it got to the big bend of the Peace, shown here, you can see it's a shallow, rocky area. Those big blocks would get caught and build up to where water would get up to several meters deep and flow back over this big flat area of the delta, rejuvenating all of those perched basins. And then eventually, as it melted a little and there was more river pressure, it would break free and flow on into Lake Athabasca and down the Slave River, and things would be back to normal. Well, before 1970, on average, there was one of those events about every third year. Since 1970, 2 things have happened. One, Bennett Dam was built. This is looking from the top of Bennett Dam down the gorge of the Peace. Nobody bothered to tell the people in Fort Chip about this. They first knew about it when it looked like somebody pulled the plug on the Athabasca Delta. It started to drain like your bathtub. But the records speak for themselves. Those spring flood conditions that occurred pre-dam, you can see here in black, this is maximum flows and these are mean flows. Once they put the dam in, that's where they caught the water to impound. So those big spring flows were reduced, and they flow the water out of the dam in winter instead. So that river power that carries, used to carry those ice blocks down is no longer there. Then on top of that, climate warming has changed the whole pattern of snowmelt. As a result, there have only been 2 floods since 1970. Well, I was up looking at that last year with some of the people from Fort Chip whom I know and who lived on the land. And someone in the group asked them, well, why don't you just, you talk about all the disappearance of these moose and muskrats and things, why didn't you just switch to bison? Look at all those bison. And they said, well, bison are really hard to hunt out there because you have to crawl through all these thorns. And my wife, who's a botanist, said, thorns? What kind of thorns? And they said, well, we don't know what they are. They never used to be here. So we went out to have a look. This used to be one of the perched lakes. Looks like a piece of bad agricultural land. And these are actually Canada thistle and sow thistle. What we think happened is that these were probably swept down and deposited in these basins in the early part of the 20th century, after they started to clear the upper piece for agriculture. But they didn't take hold as long as there was water in these basins. The seeds will live 20 and 30 years and more. So once the lakes went dry, these things come in. If you try crawling through these things to sneak up on game, you'll know what these hunters we were talking about. So it's, I think, a compound tragedy. Things don't generally happen due to single causes like pollution or climate change or damming. It's the whole package we have to start looking at. And this estimate made some time ago now projected huge decreases in populations of ducks and muskrats and other animals and in wetland area, and they've pretty well come to be true. Yet still today we hear politicians talking about hydro as being good clean power. This I took in Manitoba, part of the Southern Indian Lake development. Here where they flood these big peatland areas like the poor fen, the wooded fen that I showed you, the peat tends to lift up. Gas is generated in those sediments as they're flooded. The peat floats to the surface, as you can see here. As it rots, it discharges lots of greenhouse gases. Not as bad as burning fossil fuels, but about a third as bad. And those same bacteria that cause the decomposition methylate mercury that gets into the fisheries. And here's an example put together by one of my colleagues of several Canadian and Finnish reservoirs in the history of the fisheries. This is the Canadian consumption guideline, and you can see that most of them have had the fish go way over that as a result of this increased mercury methylation. And that pollution lasts for a long time. So you can see many of these populations 20 years after impoundment are still high. And right now we have a new development proposed on the James River Basin, the Rupert River, and of course there are Aboriginal communities at Rupert House and several other of the surrounding river mouths in that area. So this colonial era when the people who know it all just move in and take over these resources without considering, in the language that David Suzuki used this morning, Aboriginal people and their fisheries and all of these things would be externalities. I'm afraid in economic terms they still are, and that has to change. Another example where climate and pollution combine to have an effect is Lake Winnipeg. This is the biggest watershed of any Great Lake in North America. It's huge. It's 10 times the size of the watershed of Lake Erie, even though Lake Winnipeg and Lake Erie themselves are of similar size. And the reason is that this whole dry area that we're in the middle of right here is necessary to drain into that lake. And it comes into Lake Winnipeg at the Grand Rapids just about here via the Saskatchewan River. And in the early part of the 20th century, that used to be about 70% of the total flow into Lake Winnipeg. But with all the climate warming and withdrawals for irrigation and things, and several dams on that river system that I've been talking about, that river is down to about 15% of its historic flow as well. Some of my colleagues have recently started studying the lake. I was part of a study done in 1969, and they've continued the tradition by talking Department of Transport to keep a ship out of mothballs. In our case, it was the Bradbury that you can now see in the Marine Museum at Gimli. The current ship is the Namao, which is similarly on its last legs. But you can see from our studies in 1969 up until the early 90s, there was little change in the nutrients that cause algal blooms, phosphorus and nitrogen, or algal blooms themselves. But look at the middle to late 90s. They're all just exploding. Last year, this picture was taken of Lake Winnipeg by satellite. There's an algal bloom of these nitrogen-fixing floating blue-green algae that cause taste and odor and mycotoxin problems. It was 6,000 square kilometers, and it lasted for 2 months. I'm told that this summer, even being a cooler and wetter year, it's just about as big and as long-lived. I haven't seen the data yet. The problem is this river. This is the third biggest river going into the basin, or at least it used to be. It's now vying for second place with the Saskatchewan, with the Winnipeg River now supplying more water than the Saskatchewan, because the Saskatchewan has shriveled away, where the Winnipeg has been more or less normal. In this basin, we have all the rich agricultural land in North Dakota, Minnesota, and southern Manitoba, increasing hog farms, increasing cattle, slaughterhouses, all these municipal effluents from places like Winnipeg and Fargo and Grand Forks and Moorhead and several smaller cities pouring in. So this is the main source of nutrients to that lake basin. And the third thing that's happened is that they've dammed Lake Winnipeg. It's now a hydro reservoir. And if you put all of those together, if you look at the blue versus green bars here, which are the discharge of phosphorus from the lake before and after this dam went in, before and after these flow changes, that lake is now retaining much more phosphorus. So it's, instead of the phosphorus being flushed out and down the Nelson, where it immediately combined with several other big waters and had little effect, it's now being held back in the lake to cause these big algal blooms. So again, the combined effects of climate warming via sapping the flows of the river and these increasing agriculture and other activities. This is how the algae have increased in the lake over that period, where the gray bar here are these blue-green algae, or cyanophytes as they're called here, that cause all the problems. Hans briefly mentioned microcystins. The World Health and Welfare Drinking Water Guideline is a microgram per liter. This is 3,000 micrograms per liter. These are several places on Lake Winnipeg in 2003. And of course, the northern end of that lake has either a Métis or a First Nations community at the mouth of every moderate size or large size inflow, ranging from Grand Rapids, Ovid Mercredy's home, right over to Barons River and Poplar River on the east side, and on down to the southeastern part. If you look at where that lake would lie on a scientific plot, with its decreasing water input and therefore renewal time and nutrient input, it lies right up here where these red dots are, where Lake Erie lay in the 1970s when people were claiming that Lake Erie was dead. Well, we've controlled the nutrient sources to Lake Erie. It's now down here. It's been one of the success stories, of which we have several in this century, but we've got to do something about Lake Winnipeg. And this, I think, the concern for First Nations communities has to be a good part of reason to act. Well, these are some projections for the proportion that the Red River, this polluted southern river, will supply looking ahead for the next 100 years. It's now about 20% of the water inflows. Due to what climate's going to do to other rivers, it's going to nearly double that influence by 100 years from now. And its annual input of phosphorus is going to go up as a result. And the concentration in the lake, which these are fisheries and oceans predictions from Winnipeg, will again over that 100-year period increase by 30 or 40%. And that's without any more population or agricultural increases. So something has to be done to stop what's happening. And I mentioned air temperature versus water temperature. I've done plots like this many times over the years. Some of these colleagues working on the lake measured monthly air temperature at Gimli, one of the longer-term records on the lake, and water temperature. Perfect straight line relationship. If you can predict air temperature, you can predict water temperature. And to sort of make the transition to the next thing I want to talk about, these are changes in organochlorine, some of the persistent pollutants that we've heard a little bit about this morning, DDT and PCBs. They both increased in the 90s, and these studies by Fisheries and Oceans indicate that it wasn't the levels of pollutants coming in that changed. It was because of the nature of the food chain in the lake with all these increased nutrient supplies that concentrations are going up, even though we no longer use DDT and haven't for 30 years, and PCBs are supposed to be being phased out. Well, another thing that we need to pay more attention to is what's happening with land use and land clearing. We tend to think of these as forestry effects. These are seismic lines in Alberta. But in fact, as any trapper will tell you, these people ride their ATVs in and vandalize cabins and poach fish and game and generally cause a lot of mischief. And there was a day that I can remember when you had to at least be able to find your way around a little bit to go in and hunt and fish. And you had to be industrious enough to carry some stuff on your back. Now anybody who's smart enough to turn a key can jump on his ATV or in his SUV and drive anywhere. Lakes have any number of accesses to them, and the fisheries of these lakes have been taking a real kicking. And as you convert forests to agriculture, there are good solid numbers from all over the world that show more nutrient runs off a landscape like this than runs off the original forested landscape. Yet here we are. This is halfway between Grand Prairie and the Northwest Territories border. And the forests are being pushed north to grow more cattle and more grain. Doesn't make a lot of sense. And it's happening quickly. It's happening within my lifetime. This is the Swan Hills area, a 1949 air photograph. And this star will be a constant feature, the same location on this series. Well, by 15 years after that photo, they had discovered oil and gas and bulldozed in some lines and put in some well pads, and then if there was oil discovered, then they put in roads and pipelines so that the area looked like this. So what was once an area where you could only get into if you had some bush skills, now anyone can get pretty close. Add another 10 years, and once you have all those roads in there, then all the lazy folk go in and want to make a few bucks by logging it. So this is now 1983. Here's the star again. And then you look at 10 years after that. And the logged areas haven't gone back. Some have been converted to pasture. And yet there are people who will still swear on a stack of Bibles that this is good bear habitat, grizzly bear habitat. This used to be one of the biggest populations of grizzly bears in the flatlands part of the boreal. Friends of mine in the area say they haven't seen a grizzly bear in over 20 years. And then, of course, once the clearing is done, we're not smart enough to figure out what the rest of the landscape does. As soon as it gets a little dry, like the last 7 or 8 years, farmers want to get in and fill these wetlands in. They get in the way, you get your tractors stuck, and it's not efficient to use their big equipment to get around them. They don't realize that those aren't separate from the groundwater. They and groundwater are interchangeable. They push water into the ground if they're higher in the landscape, and groundwater flows back out into them. So they maintain birds, they maintain fish, and they maintain flows in the rivers and in the groundwater systems. Instead, we tend to turn our landscapes to look like this, something that only a farmer from the Ukraine could love. And these same guys will turn around and complain because their wells have gone dry. Well, it isn't rocket science. We've known what we need to protect here for 50 years. And yet, according to Ducks Unlimited, 70% of the wetlands that were on the prairies have been destroyed. And it isn't only the wetlands. The areas along river courses which keep erosion and washing of contaminants and that out of the rivers are pretty well gone. This is the Red Deer River taken on a flight between Edmonton and Calgary. This is what a river like that ought to look at. This is north of Uticuma Lake. So we've tended to strip the native vegetation, plant grain or pasture cows right to the edge of the river, then wonder why the river floods or why there's too much silt in it so it costs us more for water treatment, so on. Some pretty stupid things. We've known about them for ages. Why are we still doing them? And big sources of manure. This was a part of a big forested area. This is 2 miles from where I live. 2 years ago, this was all forest. You can see the burn piles here yet. This is in the spring of 2002. 25% manure cover on the landscape. This is a map of the Alberta Advantage. This is what we can expect to flow down our river systems and affect anybody downstream. It's why we need advances in water treatment plants and technology. But you have to ask, who ought to be paying for that technology? Why should people up here be allowed to pollute because, as somebody put it this morning, their 3,000 kids don't have a toilet when the effects are downstream? No surprise that if Alberta's own figures show that almost all of the rivers in agricultural areas are out of compliance with fecal coliform guidelines. And if you look at the various pathogenic bacteria and protozoa, they're all shared among humans, cattle, and hogs. Edmonton draws its drinking water from the North Saskatchewan River. A study by EPCOR and the U of Alberta indicated that the big source of Cryptosporidium, which has been a chronic problem for Edmonton, is the 250,000 cattle upstream. But nobody asked those people to pay for water treatment. Instead, they just installed a $10 million ultraviolet plant so that they can kill Cryptosporidium because it's resistant to just chlorination. And then there are the pesticides. Again, David Suzuki talked about the great pesticide scam. I find this particularly fascinating because my dad was a pesticide dealer. And this is a cover of Time magazine from 1947 to show us all how great this new chemical was. It would get rid of all these nasty old bugs. And I can personally remember salesmen jumping into vats of DDT to show how harmless it was. Well, thanks to Rachel Carson, we started to know better. And then people on the Great Lakes looking at fish and birds started to see some problems. This is what's called lip papilloma. And some of the bottom feeders, this being a brown bowhead and others like white suckers, these started appearing in huge proportions of the population. And some of these skin cancers, and in birds they were finding abnormalities in development. This one has had the internal organs grow so large the body cavity couldn't grow around them. Even those that lived were usually sterile and had things like crossbill syndrome shown here in cormorants. And of course, probably most tragic of all, the top predatory birds, things like eagles and here a peregrine, quit reproducing almost altogether. We should regard those as sentinels. We saw what was happening to them and we backed off using these chemicals. And while you talk to most people and they'll say, oh, we don't use those anymore. In fact, they're still produced in North America. Things like toxaphene and DDT and dieldrin are still produced. They're just sent to the tropics rather than used here. And if you look at all of the pesticides, as things are phased out, new ones come in that are claimed to be less toxic. Probably so, but we don't know that they're non-toxic at all. This is from a study that a number of us compiled a few years ago. Global pesticide use has just kept right on climbing if you consider all of the pesticides. Well, again, a surprise that we didn't know about. We thought the biggest effects would be in these areas where DDT was used. And again, I should mention that there are a lot of Aboriginal communities that are in that Great Lakes country, a lot of Mohawk First Nations, for example. But was surprising when people started studying in the 1990s. They went to the Arctic where they thought they might find low concentrations because it was so pristine. And instead, they were surprised to find some of the highest concentrations anywhere. And piecing together the pieces, and to make a long story really short, people discovered over about 10 years of investigation that these pesticides move kind of like dew moves on the grass. If you go out in the morning, it's all lying there on the grass and you get your feet wet. But then when it warms up a little bit, the grass is dry and that water's moved on. Well, these pesticides move much the same way. They have different points of condensation than water does, but at low temperature they tend to condense and land in ecosystems, and if they're warmed up again, they move off again. So in from one to several jumps, they gradually move to colder regions of the planet, both high elevations and high latitudes. I'm going to abbreviate this section a bit. We started a bit late, and I'd like to have us end up with some time for questions. With some study, we now know that there's a lot of toxaphene and chloridane and PCB and DDT movement from southern regions where contaminants are no longer used, but over the years they've migrated to colder areas. That, plus the fact that these things all concentrate in fats, means that there are tiny concentrations in those northern waters, but these things move up in food chains, and they biomagnify at each step. This is a log scale, so each number here is a factor of 10. So 10 to the 3 is 1,000, 10 to the 4 is 10,000, 100,000, a million, and so on. So by the time you get to some of the marine mammals, some of these things are 1 million times and more at higher concentrations in the Arctic than they are in the precipitation that lands there. And one of the disturbing things is that the concentrations are still pretty high. You look at deposition as rain or snow at all of these northern places, from Alert and Eureka in the high Arctic right down to the Whitehorse and Tagish Lake regions in the Yukon. And if you look at the change over time, those concentrations aren't declining. They're now declining at temperate latitudes in most of the food chain. I think we ought to pat ourselves on the back a bit that we caught something in time that we didn't have a lot of species go extinct and we didn't have big effects on humans at this latitude. But there's still concern for northern organisms. These are various guidelines, Canada and US and International Joint Commission guidelines. These are ranges of concentration. So we have organisms with body burdens higher than some of these guidelines, and they should be of concern. And particularly, these concentrate in fats, and one of the highest in fat substances of all and most nutritious is breast milk in humans. And again, if you look at Inuit versus urban women in southern Quebec, people who've eaten these country foods that are highly contaminated by biomagnification have had tremendous increases in these concentrations. The same when you look at cord blood that feeds embryos via the notochord, higher concentrations, particularly in communities that eat marine mammals. And if you compare these to recommended reference doses, the maximum daily intake, they range from 3-fold to over 100-fold higher for these different. These things have to stop. Now, you'd think we'd smarten up, but here we are. We've depleted natural stocks, so now we're raising salmon in pens. But cheapest sources of food are contaminated with PCBs and DDT and things. So while wild salmon are quite low in these things, judging by the green bars here, if you look at farmed salmon or the food for farmed salmon, they're way, way higher, to where a person only ought to be eating about a meal a month, especially if you're a child or a pregnant woman. So there's some very strange things happening still. It's like we've learned some lessons, but we haven't extrapolated from those lessons to new ones. Well, I'm going to skip forward a bit here because I want to get to what I think, we're short of time, and I want to get to what I think is perhaps important message of things we ought to be doing here. There are a number of new persistent chemicals. It isn't as though we've caught all these chemicals now and they're going away. It's generated that there are 100,000 chemicals used in the Great Lakes. 5,000 of them are produced at over 1,000 tons a year. You look at the number that we actually know are not toxic or bioaccumulative. We don't know much about them. And some examples, here's some chemicals that have just emerged. New data have indicated that they bioaccumulate. They're carried long distances, though when they were manufactured, people claimed they weren't. And some are bioaccumulative. I'm going to concentrate on the PFAS here. These are for polyfluorinated organosulfates or sulfonic acid, and polybrominated diphenyl ethers. These, well, here are some more, but to go on, these polybrominated diphenyl ethers are used in making foam. So if you lie on a foam mattress or bed, you're partly responsible for the production of these things. And they continue to be released as these old mattresses and cushions rot. These have properties almost identical to PCBs, and they've been building up in the food chains of the Great Lakes and in other areas. Data are just beginning to emerge. Polyfluorinated acids and alcohols, most of you know what Scotchgard is. Suzuki mentioned the things that you used to spray under your armpits in the old days that were eliminated because of these chemicals that cause ozone depletion. Well, 3M quietly pulled Scotchgard off the shelves, and after some investigation, people discovered why. Well, they didn't think these things were carried long distances or biomagnified. Turns out they do. And data are just beginning to emerge now. These are some of the manufacturing processes that those are used for. And we don't even know why they become so widely dispersed. It's thought that it isn't the compounds themselves, but they're degraded a little bit by bacteria, and then those are carried, and those are what biomagnifies. In this case, they're not carried, not biomagnified in fatty tissue. It seems to be in liver and blood tissue and so on. And these are the trends in lake trout over time in Lake Ontario. Fortunately, some people were astute enough to set aside some fish 20 years ago and put them in a minus 60-degree environment and keep them so that we could have analyses like this run. Doubling every 12 years right now. Not much money to find out how damaging these might be, but I submit it's time we found out. We also have huge lists of things that we use every day. We all take antibiotics when we have some sort of ailment. A lot of us take aspirin and ibuprofen and things like that. Anti-epileptic drugs, antidepressants, disinfectants of various kinds, preservatives, huge range of things that get into our water supply. Either we take them and they aren't metabolized in our body, so when we take a pee, they go straight into the water stream, or we just simply dump the leftover down the toilet, which is still common practice. Even sewage treatment doesn't remove a lot of these things. These are our Eastern Ontario data. This is the main component in aspirin. There's ibuprofen. There's naproxen, the main ingredient of a lot of other painkillers. In general, if you go to any stream, you can identify 60 or 80 of these different compounds, and no one knows what effect they have singly, let alone in combination. So you can expect that we'll discover a lot more bad things about chemicals. Hopefully it'll be in time that we can reverse them before major damage happens, as we've done with many of the persistent pollutants. So to summarize all of what I have to say, we've got climate warming coming, which is going to act as a backdrop, sort of like an amplifier to everything else that's going on. To protect our drinking water supplies, we have to bear in mind that we're going to have less of it to work with, and it's going to be concentrating pollutants more. So it's even more essential that we have effective water protection for our watersheds, water treatment, and water distribution systems. And it isn't, activities on land are not separate from those on water. Things like forestry and agriculture and reservoir construction affect any water users downstream as well. Then we have these things in the airshed that are carried in the air but cause aquatic problems in cold areas like the north. And we should be vigilant about looking for these new persistent pollutants that could have some effect, and we should be demanding that government supply the funding necessary to test the toxicity and verify the rates that those are accumulating in nature. So thank you, and I'd be happy to try and answer any questions you might have.